أعزائي طلبة وطالبات الثانوية العامة القسم العلمي لغات رياضيات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج كالكولس. النهاردة إن شاء الله هنتكلم على موضوع من أهم موضوعات منهجنا وهو Applications on Maximum and Minimum Values. Dear student of grade 3 secondary, welcome to our Maths program. Today we have calculus. Our lesson today is Application on Maximum and Minimum Value. First example. The height of a cylinder which has greatest volume placed inside a sphere whose radius lengths are equals 2r over root 5, 2r over root 3, 2r, 2 root 3r. We have a cylinder inside a sphere. The radius length of the sphere is r. Now r small is the radius of the sphere and r capital is the radius of the base of the cylinder. We have right angle triangle. Then r power 2 equals r small power 2 minus y power 2. And the height of the cylinder equals 2y. Then the volume V equals area of the base times height. Volume of the cylinder equals by r squared times the height. Then V equals by multiply 2r power 2y minus 2y power 3. Which is r power 2 multiply 2y. Then the first derivative of the volume v dash equals by multiply between two brackets 2r power 2 minus 6y power 2. And the second derivative f double dash equals negative 12 by y. Then we have the volume and the first derivative of the volume and the second derivative of the volume. The relation between the two variables v and r or v and y is v equals by r squared times h. Now put v dash equals 0. Then by multiply 2r power 2 minus 6y power 2 equals 0. Then y power 2 equals 1 over 3r power 2. Y power 2 equal positive 1 over 3r power 2. Then y equals 1 over root 3r or y equals negative 1 over root 3r. Y is the half of the height of the cylinder, then the value of y equals negative 1 over root 3r refused. Now we have critical point when y equal 1 over positive root 3 over r. Then we use the second derivative test and substitute in v double dash. Then v double dash 1 over root 3r equals negative 12 by multiply 1 over root 3r. This value is negative value. When v double dash equal negative value, then the function here has maximum value. But if v double dash is a positive value, then the function has local minimum value. In this case, v double dash equals negative 12 by multiply 1 over root 3r, which is a negative value. Then the volume is as possible when y equals 1 over root 3 r centimeter, and the height of the cylinder equals 2y equals 400. The relation between A and B can written in the form B equals square root of 400 minus A power 2. Now we have the value of B in terms of A, and the area of the triangle OAB equals half base times height, half A times B. Area A equals half A times B, which equals square root of 400 minus A2. The derivative of the area A dash equals the derivative of the product of two functions, half A multiply square root of 400 minus A power 2. Then half A, the derivative of half A equals half multiply root 400 minus A power 2 plus half A multiply the derivative of the square root 400 minus A power 2, which is negative 2A over 2 square root 400 minus A power 2, because the derivative of the root equals the derivative of the function inside the root divided twice the root. Then A dash equals half square root 4 minus A power 2, and we multiply A times A, then half times negative A power 2 over square root of 4 minus A power 2. This function is the first derivative of the area of the triangle OAB. To get the critical point, we put A dash equals 0. Then half square root 4 minus A power 2 equals half multiply A power 2 over square root of 400 minus A power 2. We can cancel half from the left hand side with half from the right hand side, and cross multiplication we get the relation 4 minus A power 2 equals A power 2. Then 400 equals 2 A power 2. By divided both sides by 2, then A power 2 equals 200. Then the value of A equal positive or negative root 10 root 2. A is the length of side, then A equal positive 10 root 2 and the negative 10 root 2 is refused. When we have A equals 10 root 2, then the function A of x, the area of the triangle, increasing in the open interval negative infinity and 0, and decreasing in the open interval 0 to infinity. The function has local maximum value when A equals 10 root 2. Then the value of B equals 400 minus A power 2, and A equals 10 root 2, then B equals square root of 400 minus 200. Then B equals square root of 200, then B equals 10 root 2. And we can write the triangle OAB has a maximum area when A equals 10 root 2 centimeter and B equals 10 root 2 centimeter, then the value of A equals the value of B and both equals 10 root 2 centimeter. Another example: if the perimeter of a circular sector is B, prove that its area is to be maximum when its radius r equals b over 4. We know the perimeter of the circular sectors b equals L plus 2r. L is the length of its arc and r is the radius of its circle. And we can write L equals p minus 2r. L equals constant, perimeter of a circular sector is a constant value equals b, and r is the radius and r is a variable value. Now the area of a circular sectors A equals half LR. Half L, the length of its arc, multiply the radius of its circle. Then the area equals half P minus 2R multiply R. Then A equals half P times R, which is equal half PR, and the half multiply negative 2R times R equals negative R power 2. Now we have a relation between the area of a circular sector and its radius R. Now to get the critical point, we get the first derivative of the function. A dash equals half P minus 2R. The derivative of half PR is half P, and the derivative of negative R power 2 is negative 2R. Put A dash equals 0, then half P minus 2R equals 0, and R equals B over 4. R equals B over 4 is a critical point. We can use the second derivative test and substitute in A double dash, which equals negative 2. Negative 2 is a smaller than 0, negative value. Then the area of the circular sector is maximum when R equals P over 4, which P is the perimeter of the circular sector and the R is the radius of its circle of the circular sector. Another example, the height of the right cone, which can be placed inside a sphere whose radius length is 9 cm, such that its volume is as great as possible equals centimeter, equals 7 or 8, 10 or 12 centimeter. Now we have a right cone placed inside a sphere. The radius length of the sphere is 9 cm, and the radius length of the base of the cone is R, and the height of the cone is 9 plus y. Then the relation between y and r is y power 2 plus r power 2 equals 9 power 2. Then y power 2 plus r power 2 equals 81, and r power 2 equals 81 minus y power 2. And the height of the circular cone, h equals 9 plus y. What is the value? What is the rule of the volume of the cone? V equals third area of the base by r squared times the height of the cone. The base of the cone is a circle. Then the volume equal third area of the circle times the height. V equal third by r squared times h. V equals third times by times r power 2, which is 81 minus y power 2, multiply the height of the cone, h, which equals 9 plus y. Then the volume V equal third by multiply 81y minus y power 3 minus 9y power 2 plus 729. This relation between two variables, the volume of the cone and the height of the cone. Then v dash equal third by multiply between two brackets, derivative of 81 y is 81 and the derivative of negative y power 3 is negative 3y power 2 and the derivative of negative 9y power 2 is negative 18y. Now we use the second derivative test. Then v double dash equals third by multiply the derivative of 81 is 0. The derivative of negative 3y power 2 is negative 6y. The derivative of negative 18y is negative 18. Then v double dash equal third by multiply between two brackets negative 6y minus 18. Put v dash equal 0 to get the critical point. Then third by multiply 81 minus 3y power 2 minus 18y equal 0. We have 0 equation. We can solve this equation and get the values of y equals 3 or y equals negative 9. The negative value is refused because y is a part of a side of a cone, or a height of the cone, a part of a height of the cone. Then y equals 3. We can use the second derivative test and substitute in f double dash. F double dash 3 equals negative 12 by, which is smaller than 0. Then the volume is as great as possible when y equal 3 centimeter. 3 plus 9 equals 12. Then the height of the cone equals 12 centimeter, and we can choose the letter D, which is h equals 12 centimeter. Another example. Find the two dimensions of a rectangle which has the biggest area and it can be drawn inside a triangle whose base length is 16 centimeter and its height is 12 centimeter, such that one of its sides lies on the base of the triangle and the two vertices of the opposite side lie on the two other sides of the triangle. To calculate the biggest area, we model the problem according to the given data and constraints. The triangle ABC with base BC equals 16 and height equals 12. Find the two dimensions of a rectangle which has the biggest area and it can be drawn inside a triangle. We draw a rectangle inside the triangle ABC such that the base of a rectangle inside the triangle lies on the base BC and the two vertices E and D lies on the two sides AC and AB of the triangle ABC. Determine the variables and unknowns by letting the rectangle width equals x centimeter and its length equals y centimeter. The area of the rectangle equals a centimeter power 2. The relation among the variables a, which is the area of the rectangle, equals x times y. A equals the width times the length. Putting the mathematical model in one variable if possible. Now, from similarity, we have y over 16 equals AD over AB equals 12 minus X over 12 from similarity. And Y equals 16 times 12 minus X over 12, which equals 4 over 3 multiply 12 minus X. Note that X belongs to closed interval 0 and 12. The value of X not less than 0 and not bigger than 12. Then the area A of the triangle equals 4 over 3x multiply 12 minus x. This area is a function of x. Then A equals f of x equal 16x minus 4 over 3x to the power 2. By solving this mathematical model, we have differentiating both sides of relation 2 with respect to the variable x. Then f dash x equals 16 minus 8 over 3x, and the second derivative f double dash x equals negative 8 over 3, because the derivative of 16 equals 0 and the derivative of negative 8 over 3x is negative 8 over 3. Now, when f dash x equals 0, then x equals 16 times 3 over 8 equal 6. And we can substitute in f double dash x. Then f double dash x smaller than or equal 0, because the second derivative equals negative 8 over 3 is a constant negative value. A has an only critical point when x equals 6 and the second derivative is always negative. Then this critical point gives the absolute maximum value. The function A, which is the area of the rectangle, has an absolute maximum value when x equals 6 and y equals 8 over 3 multiply 12 minus 6, which equals 8. Then the rectangle has the biggest area when its two dimensions are 6 centimeter and 8 centimeter. If the two dimensions of the rectangle 6 and 8, and we draw this rectangle inside at a triangle ABC whose base length is 16 centimeter and its height is 12 centimeter, then the area of the rectangle has the biggest area when the two dimensions is 6 centimeter and 8 centimeter. بكده اعزائي نكون استعرضنا مع بعض الاكزامبلز اللي بتكلمني عن الابليكيشنز اون لوكال ماكسيما اند لوكال مينيمم. عرفنا ازاي نقدر نعمل ريليشن او نكون ريليشن بين الفاريبلز اللي دخلت معايا في الاكزامبل. لازم نقرا الاكزامبل كويس ونكون ريليشن بين ذا فاريبلز. سمينا كل فاريبل باسم وعملنا ريليشن بينهم. ريليشن طبعا هو اللي لي في الاكزامبل، سواء قال لي اريا او فوليوم او بريمتر او سيركمفرنس، ايا كانت الريليشن هيقولها في الاكزامبل. هبدا اكون هذه equal 0 we have a critical point. critical point ممكن نشتغل بالفيرست derivative test or second derivative test. first derivative test هنشتغل على increasing و decreasing ونعرف الفانكشن increasing و decreasing ولا decreasing و increasing، وبكده نحدد البوينت اذا كانت local maximum او local minimum. او هنشتغل بالسكند derivative test ونشوف الدبل داش at x equal الفاليو اللي طلعت لي عند الكريتيكال، ونشوف لو الاف دبل داش عند هذه الفاليو equal positive value يبقى